so everyone should see this. I can't see you and I can't see chat, so I will take a look at that, or if something comes up that needs my attention, just someone yell at me. Morning, everyone. I'm Ian Whitney, part of the new ASR data engineering team. We're a few months old. I'm going to be talking today about getting data into Splunk, what sort of data is great to put in Splunk, and how to get it there. I'm not going to be talking very much about what you do with the data once you get it into Splunk. There's a lot of other resources available for that, Splunk training, a bunch of YouTube videos. There's a lot of things to do with once you've got data in Splunk. I will talk a little bit quickly about what Splunk is. Their description on their site, it's software for searching, monitoring, and analyzing machine-generated data. It's hosted and run by within the UIS team within OIT. I don't know how long we've had it, 8 years or so, roughly at this point. But basically, you take any sort of machine-generated data, you shove it in there, and it gives you a lot of great tools for analyzing, researching that data, building dashboards, and most importantly, alerts. Just really what within ASR we mostly use it for, ensuring that our applications are healthy, a lot of alerting around, this service returned to 500 error, or this database is down, or et cetera, et cetera. Dashboards, which we use just to kind of track ongoing health of services. And then when things do go sideways, we'll spend a lot of time in Splunk researching the logs to see if we can figure out what went wrong. Like I said, we're going to talk a lot today about generation of data, ingestion of data into Splunk. We're not going to talk about working with data in Splunk. We'll talk a little bit first about generation. You have a lot of options here. The options that we've really dug into within ASR are these 5: application logs, instrumentation, API responses, database queries, and server metrics. These all offer a lot of great ways, like a lot of great data that you want to generate and get into Splunk. There's some general advice for generation, though. This applies to everything I'm going to be talking about. But the first one is the more structured your data, the better. JSON for us has kind of been the best approach. If you can generate data in a JSON structure and put that into Splunk, it's going to be very easy to search and work with. If you can't do JSON, then look for some other sort of very structured approach. CSV is fairly structured, right? There's always exceptions to CSV. XML, it's a structure. Random text, you can work with it in Splunk. It's just going to be harder. And the more identifiers that you can get into the data that you put into Splunk, the better. And by that, I'm talking about things like your application name, the server, although that's kind of automatic, the version that you're running, timestamps, anything that you can get in there to identify the data so that you're going to be able to really refine your search and understand what's going on, you're going to have a better time. The first kind of data that we've been generating a lot of, and where we started with Splunk and where most people start with Splunk, is with an application logs. You probably already have these sitting on a server somewhere, moldering away. Maybe you had at some point to write a process to delete those logs once every 90 days or whatever, so they don't eat all of your hard drive space. We definitely did a lot of that. If you can write those logs out into JSON format, which some application platforms or tooling lets you do very easily, Rails, not so much, although it's improving. If you can write that stuff out into JSON, great. This is the sort of like Apache logs, application logs, the sort of stuff that comes with things that you're already running that's right now being written out to disk. It's a great place to start generating data that you're going to put into Splunk. Here's an example, right? This is Rails. When I talk about Rails, actually, I'm sorry, this isn't Rails. This is actually Apache Kafka. Logging some API interactions. This is just not structured, particularly well-structured text. It is structured. It's just not as structured as maybe some other approaches. This is just using log4j. This sits on a disk somewhere. This is great stuff to get into Splunk, right? You can see here that there's a 200 response. You can see what they were trying to hit. You can see an IP. You get a lot of great stuff here. Another option that we've been using for generation of data is instrumentation. This is kind of a concept that's offered by a lot of kind of application frameworks. We use Rails a lot, so we're using Rails flavor of this. and you kind of write some code to observe the code as it runs. This is kind of an example of how this looks in Rails using this notifications instrument method. You make a block around a method that you want to see what it's doing, how often it runs, how long it takes, whatever sort of stuff that you care about. Magic happens there in the middle. And then what pops out is this very nicely structured chunk of JSON. You get kind of logging levels, you get some severity, you get a timestamp. There's identifiers that I talked about before, where you've got things like the program that's running, the environment that it's in, the version that it's in. And then you get some details about that method itself, like when did it start, when did it finish, and how long did it take? This is great data to get into Splunk, right? If you want to find out how often methods are being called, hotspots in your application path, what's taking long time, what's taking a short amount of time, that sort of stuff. This is a great example of data to generate to then later put into Splunk. Another option we've been using is API responses. Maybe you have a service that you run yourself that has some health point or health check endpoints that you can hit and says, hey, I'm healthy. Or you're running like a vendor service and it comes with some REST API components that you can hit and it returns back to you some data about the health of the service. These are great because they usually return JSON, kind of in normal modern vendor stuff, or maybe XML, or maybe just some random text. And you can kind of have APIs that respond to a lot of different endpoints and give you different kind of health data or metrics about your application. This is an example of a service that we run. It's a vendored service. It offers a health check API. You just ping that thing with curl, and you get back this great bit of JSON. And if I ever want to know later on, once I put this data in Splunk, if my application is not healthy, well, it's right there. It's the top thing. Are you not healthy? Cool. Make an alert and let me know. You can get a lot of great stuff out of API endpoints. And I think this is the last thing. Maybe it's not. Database queries are a thing that we're exploring a lot of. We spend a lot of time thinking about the health of our applications. And at least within ASR, we spent less time thinking about the health of what was going on in the database. And we actually do a lot of stuff in databases. We have a lot of scheduled jobs that run to refresh materialized views or do various other data transformations. And the nice thing about databases is they contain a ton of metadata that you can track. And they also allow you to return query results as JSON. And you can kind of combine these things and generate within your database a ton of really useful metrics about the health of things. Here's an example of an Oracle version of this, which has got that JSON kind of hint at the top. And you can say, hey, go to my important application table and tell me the most recent update to this table. Maybe you've got a column in there that's a timestamp that just gets written to the current date whenever a record gets updated. And Oracle will just spit out some JSON for you. And there's a ton of stuff. I spent all of my time in Oracle, but I know there's options in other databases as well, where you can write a lot of queries that get at metadata of your tables or other things that you've got going on in your database, return them as JSON, and then use that data later in Splunk to find out the health of what's going on in your database. Oh, and the last one here is server metrics, right? Within the server itself, there's a lot of tools you can use to say, hey, server, how are you doing? Things like top and CPU and VMstat. I'll mention this later when we talk about ingestion. All this stuff actually already ends up in Splunk already, thanks to OIT hosting. But if there are other tools that OIT is not already automatically ingesting that you want to run on your host to check the health of the operating system or the memory or whatever, you can do that, and then later on we'll talk about ingesting that data into Splunk. So that's kind of the types of data that you can generate or that we have generated. It's not exhaustive. There's a lot of other options out there, but that's what we've been doing. Let's talk about getting that data from your servers or wherever it's being generated and getting that stuff into Splunk where it can actually be used. And again, I've seen 5 options here. The number one option is have the Splunk team do it for you. You can also use pipelines that already exist that's mostly written around syslog, journald, that sort of stuff. You can send it yourself over to Splunk using what's called the HTTP endpoint collector, or HEC. You can use an integration platform, which is also secretly under the covers HEC. And then there's one I'll mention briefly called like other, which is tooling like OpenTelemetry or JMX or things like that. So your first option here, ingestion, is have the Splunk team do it, which is how ASR started with Splunk several years ago. you go to the Splunk team and you say, hey, I'm going to have this log file. It's going to be on this disk in this location, and it's going to be in this format. And then they then work with you to make sure that data gets ingested correctly. And as long as you kind of follow the patterns of always storing the file in the same format and in the same location, it'll end up in Splunk. It's great. Downside here is it takes a long time, right? The Splunk team is very busy, but on the upside, you don't have to do very much work. On the flip side, though, you do have to remember whenever you add a new host or get rid of a host, you have to let the Splunk team know to go get your files from that new host. That definitely bit us more than once, where we would start a new host, forget to let the Splunk team know, and then 6 months later go look for the logs and be like, oh, there are none. None of that stuff got ported into Splunk automatically. So a little bit of management here, a little bit slower, but it does get you results. Here's an example of this. This is actually a Rails log thing. We worked with them to build a importer for our Rails logs, which are JSON-ish mostly. And as a result, we can get data into Splunk and we can see a lot of stuff here, and it works out pretty great. So that's one option. Another option for ingesting that data into Splunk is to use methods that already exist. I mentioned when talking about the generation of data that a lot of those server tools, top, BMstat, things like that, automatically end up in Splunk. And the way they're doing that is they're just ingesting basically everything out of syslog, they're ingesting into Splunk. So if you could write something to syslog, it also ends up in Splunk. I tend to do that by having things log out to journald, either through a systemd process or run it in Docker and using Docker's logging tag to say log to journald. And as a result, like I just kind of have this automatic pipeline of getting data from my host into Splunk. A real important thing here, I've talked about that tagging before, those identifiers. It's even more important here because the syslog is very noisy. There's a ton of messages in there. And if you can't find your messages out of that massive haystack, then there's no point to this, right? So the more identifiers that you can put in there to make your messages identifiable, the better time you're going to have. And the other downside to keep in mind here is that ingestion is out of your control, right? This is a pipeline that's managed by OIT hosting. And I don't see OIT hosting ever being like, we're not going to ingest syslog anymore, but they could. Or they might change that pipeline so that your messages aren't being included, or maybe there's a lag, or you just kind of lose control of things here. You do a lot less work, but you also then end up with less control. This is an example of something that we're doing with this. I have a Dockerized process here that is just outputting its logs to journald, which then ends up ingested into Splunk. I'm logging everything here as JSON, so it's very easy for me to format and dig around and see sort of stuff. So a lot of great tooling in here, a lot of great ways of researching this sort of Kafka process. If you want to take more control over when and how you send your data, you can use HEC, or HTTP Endpoint Collection. It's a REST API that you can use to send data to Splunk however you want. You need to get a token from the Splunk team, and once you have that token, it's a simple post request, I think, to send the data over. It's not like an OAuth 2 sort of thing where there's back and forth sort of things. It's just a one-shot request. You don't have to do anything particularly fancy, and you send your data over HTTP. I recommend JSON. You don't have to do JSON, but I recommend JSON. There's now code for you to manage here, though, right? Like you now have this thing that is taking whatever data you're generating, pushing it over to Splunk. HTTP is great, but it's not like it's 100% reliable. Things fail, network goes down. How do you handle retries? Are you okay with losing data? You're probably managing some of this stuff now that you weren't managing before. So an option comes with some definite positives and some negatives. This is an example of something we have, though. This is within workflow gen. Whenever a stored procedure runs, it gathers some data about that stored procedure and then posts that using HEC over into Splunk, and we're then able to see a lot of great stuff about that workflow gen procedure. What data is it returning? What environment does it run in? Was it successful or not? We get some MPLID and STRM stuff. I've hidden the MPLID there. Which process? How long did it take? There's a lot of great tooling in here that we're using in Splunk. Another ingestion option is what I call other or integration platforms. I don't know if there's a real good generic name for this sort of stuff, but in things like Fivetran or other sort of like, will easily move your data from point A to point B sort of stuff. A lot of them offer a way to easily send data into Splunk. And if you look under the covers, I think it's always HEC. You know, they require that you give them whatever your HEC token is, and then they're able to just post all that data to Splunk. We use this a lot within Kafka. Kafka has a connector that sends data to Splunk. The Splunk team, not our Splunk team, but like the Splunk corporate team wrote it. And it's just HEC. It reads messages from Kafka and it shoves them into Splunk. We've also been doing this with Boomi, using just a Boomi's HTTP connector to push data into Splunk. There's some more refined ways of doing that. There's a lot of other options in this space. You know, you get all the benefits of HEC, but without having to manage all that integration code, right? You are no longer responsible for handling HTTP retries and all of those things. So it's a nice approach if you have that sort of option. And this is just one we did from Splunk. We've been experimenting with, not Splunk, Boomi. We've been experimenting with Boomi and creating our own API endpoints with Boomi. And we wanted to be able to log every time those API endpoints are called and how long they took. So this is a start at that, not fully refined yet. And there's another option, right? If you go look on the Splunk corporate website, they offer a lot of either free or paid, in some cases, connectors that allow you to hook into kind of observability or other tooling built into programming languages that let you get at deeper metrics. Within the Java space, there's this thing called JMX. There's a move right now in this thing called Open Telemetry, which is kind of like a multi-business collaboration to make a kind of a platform for getting at deeper observability metrics. And there's tooling within Splunk that lets you hook directly into those things without having to manage your own ingestion of data. These are going to be entirely managed by the Splunk UIS's Splunk team. And so it's entirely up to them if they want to install these things or not. But if you are interested in those sorts of things, then you can ask. And maybe if enough people ask, they can say, well, there's clearly a demand for this and we're going to take it on. But entirely up to them, not something you can just do by yourself. The final and maybe key point to all of this is that there's a lot of ways of generating data and there's a lot of ways of ingesting data. You do not have to pick just one, and you can combine them in any way you want, right? Like if you have a database query that you can run, that you write out to a result out to a file in JSON, and then you have the Splunk team ingest that JSON file, that's a great way to do it. Or you can take that same database query and then you can write the results to Kafka and then ingest it through HEC. Or any sort of mix and match here, the ways you want to generate data and the ways you want to ingest data, they will all work together. So it's not like you have to pick one from each column and only use that. We use all 5 on the left and we use all 4 on the right, and different ways to meet whatever needs we have at that time. And then finally, just a shout out to the Splunk users channel on the UMN IT Slack. That is, the Splunk team is on there and they will announce if there's going to be downtime or things like that. But it's also a great place to come in and be like, hey, I'm trying to figure out how to do this work. And a lot of people there know way more about Splunk than I do. And it's a great resource. But with that, I just wanted to see if anyone had any questions. And I'm going to stop sharing my screen now so that I can see chat.
Thank you, Ian. That's amazing. Yeah. Any questions for Ian?
I had a question, and maybe you're not the best person to answer this, but in terms of like the amount of data that gets generated, like sometimes when I'm writing stuff to Splunk, I feel like we're generating just a giant amount of data. Is someone going to tell me like if there are caps or if we're generating too many log messages or something, or don't worry about it, just send as much data as you can?
I haven't run into a problem with the amount of data generation. I will say it's going to be tough for you to over-generate what's already coming out of syslog. It's a lot. What what I've heard from the Splunk team though is Splunk gives you a couple different ways of working with data. There's kind of scheduled ways of searching, and then there's real-time searching. And that's where things get constrained. Real-time searches, especially, you can't do real-time alerts at all. That just isn't allowed. And real-time searches, you can start them, but sometimes you'll just find they get mysteriously killed on you because you're taking too much. But I haven't run into a problem with the amount of generation.
One of the interview questions that the Splunk team will ask when setting up a new intake method is they're going to ask you how much data you're going to be planning to send them, because the licensing is actually for Splunk is based on how much data is going through there. So if you have a fire hose, you might want to make sure that you're choosing the right, if there's filtering up front, you can do on that, or to help keep that sane. But do keep in mind that we are sending all of our LDAP logs there, which is a lot. So like Ian says, it's hard to break them.
Yeah, and I think there's a difference between what Splunk might consider a fire hose and what like ASR might consider a fire hose. Like it's a different scale, right? And like it's worth having a conversation with the Splunk team about kind of volume, and understanding that volume is always useful from a data generation point. But yeah, I mean, Splunk is designed to work kind of at a much higher scale than I think most teams are really going to be tackling.
That being said, if you have something that's super chatty, you can try to send it all to the endpoint collector. It's very easy to hit that point where it just starts like dropping things left and right.
Yeah, you can get back pressure, slow response, or just dropped things, which is the downside of kind of running your own HTTP setup, right? You then have to figure out how to manage that stuff.
Yeah. What I found so far is usually what that has also meant is that we were sending a lot of useless junk that didn't need to go in anyways. So that was just our use case.
I think you're muted, Travis.
Oh, yeah, I stopped talking.
Mouth is still moving.
There's a question in the chat. I don't know of a limit, like Travis was saying, like if you start trying to overwhelm the HTTP endpoint, the server will stop responding to you. But I don't know of a that's not rate limited anyway that I've ever seen.
Yeah, and I didn't try to measure the limit. It's just like AKS is super chat, and we try to send all the logs from Azure itself, and that would just drop packets all the time. So it put them in an event hub, like, so we didn't like totally lose the data, but I did start to notice that there were just thousands and thousands of records. So we kind of had to filter that down.
Yeah, there's definitely a downside to sending too much data, right? You can overwhelm yourself and make it then also hard to research the valuable things later on. That's a balancing act.
I mean, for our team, like everything we run is pretty much in Azure, so we don't really, that's like kind of our one option, so make it work.
All right. Well, thank you, Ian. Yeah, that was great.
Thanks so much for giving me the space.